What I'm going to try to do very rapidly is talk a little bit about New York State's, talk about New York State's strategy in really promoting this public-private partnership model. And it's been a concerted effort which has culminated in the creation of SUNY Poly, which, as Joan had mentioned, has a statewide presence and a huge amount of research and development and deployment activities underway. The business model that allows for this to happen is that we really try to create a Switzerland-like environment where partners can pool intellectual assets. New York State has invested in the infrastructure to enable this, and the college works very diligently to protect intellectual confidential information to allow partners to participate in a variety of ways, some of them consortia, some of them proprietary, some of them vertical teaming, all concurrently at the same site. We've been expanding that model across the state under Governor Cuomo's vision, including 3 hubs now out in Buffalo. The most notable for our discussion today is the Buffalo Information Technology Innovation and Commercialization Hub, which is a partnership with IBM, setting up a major data analytics hub in Buffalo. But also you'll see a variety. The other one I'd want to point out are SMART Systems Technology and Commercialization Center in Rochester. They make sensors. Just think of it as eye, ear, nose, tongue on a chip. Actuators known as micro-electromechanical systems. And then our most important, I think, is our Smart Cities Technology and Innovation Center in downtown Albany that I'll speak to later. About a month and a half ago, we announced a major partnership with General Electric. It is in the area of wide bandgap power electronics. This obviously is very important for transportation. Being able to handle higher voltages and to control the switching of that power was really one of the elements that made the Prius work in the marketplace, so that it could transition back and forth between stored power and produced power in a seamless fashion. That, as you see, this model has resulted in an open innovation ecosystem. And when we talk about open innovation, we're talking about partners that are collaborating and sharing portions of their intellectual property portfolio in order to achieve, to address the challenges of compressing that research and development timeline, to leverage resources or burden share those resources, and to deal with the increasing complexity in the technology development. So you'll see a variety of chip companies. Joan had mentioned some of them, but the entire equipment supplier chain, material suppliers and site service companies. But concurrently, we also support research consortia that are sponsored by the semiconductor industry and funded, also matching funding provided by New York State, that are looking at longer-term solutions for moving signal around on a chip. But as well as Department of Energy, DARPA, AFRL are all here doing a variety of different programs and projects. And then concurrently, we host industrial consortia like Semitech, like the G450. The next generation of computer chips will be made on a much larger scale wafer. And so the semiconductor industry needs to align itself to overcome these challenges in the marketplace. So how do we do that? We do that by supporting each phase of the commercialization process, from the research phase to the development phase to the deployment phase. And so you'll notice our panels in the afternoon are set up in each of those phases. And the first phase this afternoon, you'll hear the academic partners who are focusing on modeling and test beds. The second panel, it will be focused on development, are our industry partners developing integrated and interoperable solutions. And then finally, government partners focusing in on the deployment phase, which are really in the area of autonomous and connected vehicles. Government is a critical partner, in a way serving as a potential barrier to the deployment of the technology. How we've been able to align all of these partners who are focusing on the different time frames is by establishing confidential state-of-the-art facilities where they can correlate data in a secure software module. We've now replicated this first for logic and memory. We now have it for sensors, MEMS, wide bandgap power electronics, and now we're moving into silicon photonics, which I'll say a few words a little further in the presentation. So when you look at kind of the nanotechnology and you look at the role of the college, we're really focusing in on enabling the smart systems and cloud computing revolution. So under semiconductors, we have established consortia, power electronics, a new center, sensors and actuators, our MEMS sensor, device packaging is a new facility coming up in Utica. And then one that's coming up, a new announced solicitation at the federal level called the National Network for Manufacturing Innovation opportunity is on the horizon that will have a dramatic impact on wireless and communications. So when you look at the applications, you see broadband and wireless being the first. And that was really driven by academia. At the beginning of the internet, it was really large data being transferred between educational and national labs. The scientists needed to communicate better. And that ultimately culminated in broader across the economy. Next came in 2007 what I would call consumer-driven or location-based services, and that was the smartphone. And when that happened, that was when cloud computing suddenly became relevant, because now you're taking embedded intelligence in the phone, your location, combining it with data that resides in the cloud, the location of a restaurant, and putting the two together, we see how powerful that is for our social lives. And then finally, the defense-driven, what I would say soldier in the field, situational awareness, robotics. Certainly we've seen the drones have become an integral part of our national defense. Anybody seen the DARPA dog? And then of course the soldier and lighting that load for the soldier. And then finally, the last is, I would say, a public-private partnership-driven, which would be the smart grid, smart cities, smart transportation applications, where the complexity is going up. Each time you can see that complexity rising and rising. So the president, about 2 weeks ago, called for actually about 2 years ago, established the National Network for Manufacturing Innovation. And the goal is to establish regional clusters of manufacturing innovation across the country to share infrastructure, intellectual property, do contract research, and have performance metrics. That is, in effect, what the Federal Department of Transportation is launching with their first wave pilot deployment projects. Now, in this case, we're talking about manufacturing chips or 3D printing or other aspects. DOT is looking at it from systems-wide, integration of all these elements within a complex system. The one that was announced 2 weeks ago is in the area of integrated photonics, what's called silicon photonics. And this is a technology that is going to come on the scene that has enormous impacts on driverless, on autonomous and connected vehicles, as well as smart cities at large. In that we've long had the fiber optic being able to move large amounts of data across the world. And we have really fast computer chips. The chip that's in your smartphone is the equivalent of what a supercomputer was about 10 years ago. The bottleneck has been getting that data from the fiber into the chip. Silicon photonics brings light, the control of photons within the chip. And it will now allow for massive amounts of data to be processed at massive rates of speed. The federal government has announced a $110 million competition. CNSE, or the SUNY Poly, will be taking the lead in putting together a response to that. But the impact that everyone should care about is that it's going to have huge impacts on data and communications. Think of 70% savings in power consumption in a data center. Huge impacts on mobile platforms. Defense and aerospace being the first adopter, where you have enormous amounts of sensor inputs. And this over here, you can see the data inputs, massive amounts of data input feeding in, being able to be processed by the logic processor, and then stored in an equal rate of speed. And you can imagine flying a plane at Mach 3 and having a missile coming at you and being able to process fast enough to have a reaction that's going to save your life. And then finally, the smart cities applications. And I would put autonomous and connected vehicles as one of the first adopters of that technology. So, the 21st century challenge and opportunity. What I would call is the smart cities device, system, and field level integration. And here, this is an interesting slide. It's a little dated, but it shows the number of sensors that are in your smartphone today. I think I counted 14. And with those 14 sensors, an enormous number. In fact, I think the Apple iStore has over 1 million apps that you can purchase or download for your car. So think of that as the smart systems enabling the smartphone, and that the smartphone provides a platform for the smart cities or the Internet of Things. But what is a smart city? It's really the integration of the intelligence infrastructure with, in our case today, transportation infrastructure that's focusing on markets, operations, and services. But what you start to see is that it gets very complex. The ecosystem is at sensor layer, access networks, data storage, cloud, and then all the different applications across. So this, you begin to get a sense of the challenge that's in front of us. And I like this slide. I adapted it from IBM's Global Technology Outlook in 2009. And they really capture what's, at the device level. You have the logic and memory, the sensing, positioning technology, but then integrating that into smart systems. So smartphone, smart transportation, and ultimately smart biomedical applications. But of course, cloud and data analytics, cybersecurity, and the apps are all implicit in the power of those systems. And then finally, the last is when you deploy it into the actual field. And now you're looking at field level. So this is bringing in the road designers, the engineers of the bridges, the tunnels, all of that aspect of it. And the opportunities for transformational hybrid systems, entirely new ways to think about how we deploy our technologies in the transportation arena. Of course, the barriers are fragmentation, but also the complexity, and also the legacy of systems. We have old, new systems. It's hard to, everything has to be an incremental change. So when we look at overcoming technology, business, and market barriers, we see the New York State public-private partnership model has a focus at its essence in this space on the technology validation. So first, companies, their first question is, okay, can we integrate, and is this system interoperable? We need data capture, we have data telemetry, data analytics. It needs to be real time, it needs to be responsive, secure, and resilient. The next question, though, is business validation, which means overcoming market barriers. So in this case, you're looking at, do we have industry standards so that everything is communicating seamlessly between vendors and applications? Testbed demonstrations become critical at this point. Regulatory environment, so the government has to allow us to do this. And then, of course, having a skilled workforce that understands both the hardware, the software, and what we now call mechatronics, the merging of those two worlds together. And then finally, market validation, the ability to replicate sales. And this is where adjacent market opportunities, next to autonomous and connected vehicles, into the smart cities, into the industrial Internet of Things. All of these are important because for the companies to make these enormous investments, they need to have a market that's even bigger than the transportation market. We all think that's a pretty big market. That's nothing compared to healthcare, right? That's the ultimate in complexity, I think. So our D&D capabilities, smart systems networks, and open innovation culture are critical to success. So when you look at autonomous and connected vehicles, we heard Joan mention that there's 8,000 semiconductors. 41% of them are analog, and 39% are digital. Analog would be devices that interact with the world, that have a curve like this. Digital, on, off, that's what logic and memory is working in. Those two come together to make dynamic decisions that are embedded in it. So the thesis of today is really the leveraging the autonomous and connected vehicles as a catalyst for smart city technology commercialization. Why? Well, if you look at Joan had mentioned the ITS, Intelligent Transportation Systems, have been at this since for 20 years. And they've developed a framework for the standards, the applications, and even research activities under organizations like the UTRC. So within that, they've set up 6 sets of standards, transportation standards, if you will, not necessarily data protocol standards, 7 ITS application categories, including 56 specific market needs, and we'll hear a little bit more about that today. And there's been, just in our UTC here for Region 2, 340 papers, which my student Munzerine has done a project on, and we'll hear some of the results of that later. But also, most important, the Federal Communications Commission allocated 75 megahertz of the 5.9 gigahertz spectrum recently, just about 3 weeks ago. The only other allocation that's been made for that bandwidth is military radar and satellite communications. So I submit in Smart Cities, this is the only place where all of the fundamentals are in place to build and deploy these solutions. Add to that the ability to easily capture the data. So all of these cars and trucks have onboard units. What's missing that captures the data from those 8,000 chips? Right now that data just sits there, unless it goes into the shop and then the mechanic downloads it. But if we can capture that with an onboard unit that wirelessly provides that data, our modelers can begin to play with that in a variety of different ways. And then finally, the upcoming RFP is really the equivalent of the NNMI for systems integration. So it really is a call to action. And so what we've put together is 4 panels today. I like to think of them as the 4 wheels. I was going to put tracks in between. But we're going to first hear at the research phase, where the modeling testbed discussion will be captured. The development phase, we're going to be hearing from Cisco, General Electric, Analog Devices, Mad Glory, a smaller video game company that plays in transportation, which I think will be exciting, and IBM. And really, hopefully, capture a understanding of the challenges and opportunities at the various levels. And then deployment phase, we're looking at really government-directed frameworks that New York, I think, is at the leadership in, with capabilities to enable the deployment of autonomous and connected vehicles. And then finally, investment. Startup New York, a representative from Startup New York at Empire State Development, Bloomberg, Armory Square, a venture capital fund, but a smart parking meter company, one of our own success stories here, who, Mad Glory, is the software designer for that smart parking meter. So I think we're going to have a really nice discussion today. I'm very much excited about the opportunity. I'd like to close with this slide. It's a slide I took from Carlotta Perez. She wrote it on Technology Revolutions in 2002. And at that time, she was looking at, and what she does is she profiles the eruption of a technology. That eruption generates an enormous amount of wealth. That wealth results in bubbles. Those bubbles eventually pop, and there's a frenzy. And then there's a technology trigger that precedes a plateau of productivity, the broad-based deployment of this technology. And what she, at the time, thought the dot-com bubble popping was the frenzy. We now find out in retrospect that it was really the 2008 financial collapse. And what I did is I put in my thoughts on what I see as the technology trigger. I see the launch of the Apple iPhone in 2007 as the alignment platform that we all is now spread across the world. And I would add the deployment of silicon photonics, which would be around the 2016, 2017 array, as providing us with all of the elements that we need, technologically speaking, for broad-based deployment of smart cities transformation. So with that, hopefully I think we're going to take a break after this. And if anyone would like a quick tour during the break, we'll just lead some people over to one of our clean rooms right nearby. And you're more than happy to come along, and we'll kick that off for the next 15 minutes. Thank you very much.